Hey, we're going to talk here about rhombuses, rectangles, and squares, and their sides, their angles, and their diagonals. Oh boy, let's get started. So, first of all, what are these things? They're all types of parallelograms, right? So this big white box represents all parallelograms, but two special kinds of them, the red circle and the blue circle, are rectangles and rhombuses. So remember, the definition of a parallelogram is two pairs of opposite sides that are parallel. So what's special about rectangles is not only are the opposite sides parallel, but what's right about rectangles? The angles, 90-degree angles, rectangle. That's kind of rect is a way it means right in this, historically speaking. That's what that means. So right angles in rectangle. So all the angles are congruent. A rectangle is a parallelogram where all the angles are congruent, 90, 90, 90, 90, congruent to each other. Is that true in this rhombus? No. So what's special about a rhombus? Well, if a rectangle has all angles that are congruent, maybe you can guess that a rhombus has all sides that are congruent. Rhombuses are equilateral. That's why we were able to construct them with compasses earlier, kind of easily, because they're equilateral. What's a square? As you can tell by the definition, a square is both equilateral and equiangular. Therefore, we say it's regular. But okay, that's what these things are. Now let's talk about their properties. All right. First of all, what do we see about their diagonals here? Their diagonals are perpendicular. Diagonals are perpendicular. Second thing, so these all seem to be about these two are both rhombuses. This one's a rectangle, rhombuses. So first of all, their diagonals are perpendicular. Secondly, their diagonals are bisectors of the angles of the rhombus. Now you may remember from parallelograms we had diagonals that happen to bisect each other. So that's true here too, right? This is if I draw a parallelogram, the diagonals bisect each other. That means this side is equal to this side of the diagonal, and this side is equal to this side. But what this is saying, in addition, for a rhombus and a rhombus only, it's also not only is it a bisector of the other diagonal, bisecting the side, but it bisects the angle. Bisects that angle, bisects this angle. So the diagonals of a rhombus are angle bisectors as well as segment bisectors. So those are rhombus theorem. All right, what about this last one? It's a rectangle theorem. Its diagonals are congruent. Parallelogram is a rectangle if its diagonals are congruent. So note, like, if it was a parallelogram but not a rectangle, then yeah, the diagonals bisect each other, so this is congruent to this, but it's not congruent to this. This one is separate, a different length, right? And you can see that in the diagonal, like this is a parallelogram, but AC is longer than BD. But in this special parallelogram, this rectangle, AC is equal to BD. All right, so those are the theorems about rhombuses and rectangles. Let's try some examples. Let's try some problems. Okay, so our first problem says, is it always, sometimes, or never true a rhombus is a rectangle? Is a rhombus always a rectangle? Well, not if you look at our little theory. You see this is a rhombus, this is a rectangle. Just because it's equilateral doesn't mean it's going to be equiangular. But sometimes it is, then it's a square. So I'd say sometimes. For A, I'd say sometimes. A parallelogram is a rectangle. What do you think about that one? I think sometimes, because again, parallelograms are sometimes rectangles, because this whole box is all parallelograms, but not always. So sometimes for both, for A and B, sometimes. All right, next example. Okay, in this example, we're given that this is a rhombus and we're told to solve for y. So basically, we just need to remember what the heck a rhombus is. What's special about a rhombus? All its sides are congruent. So therefore, 2y, 2y plus 3, that's one side, equals 5y minus 6. And now we solve. So I want to get all the y terms on one side and all the number terms on the other side. And then since I like positive numbers, I'm going to try to keep it positive. So subtract the 2y from both sides, and I'll get 3 equals 3y minus 6, and I'm going to add the 6 to both sides, and I'll get 9 equals 3y. I'm going to divide by 3 on both sides, and then I'm going to get y equals 3 equals y. Yay, rhombuses. You can plug in my answer and double check. 2y plus 3, that's 2 times 3 is 6, plus 3 is 9. 5y minus 6, that's 15, minus 6 is 9. So they're both 9, that's good. It's a rhombus. Last one. You're building a rectangular frame for a theater set. Ooh, we're building a theater set. So we need a rectangular frame, 6 feet tall, it's tall as a person, 4 feet wide, and we use pieces of wood nailed together as shown in the right. What is the shape of the frame? Well, I don't know. It seems like it's rectangular because it says rectangular here. But I can't say that for sure yet, right? What I can say based on 6, 6, 4, 4, since the opposite sides are congruent, I know it's a parallelogram, right? I know it's a parallelogram. That's all I know, I think, based on this drawing. Let's get a little deeper. To make sure the frame is a rectangle, you measure the diagonals. One is 7 feet 4 inches, and the other is 7 feet 2 inches. Is the frame a rectangle? Explain. Well, let's go back and see if we see anything that helps us with this problem. How about this theorem? Any theorems on this page right here help us with this problem? Which one has to do with rectangles? That'll be this one down here. What's it say? Parallelogram is a rectangle if and only if its diagonals are congruent. What do you guys think about that? Probably you think, well, this one has 7 feet 4 inches and 7 feet 2 inches as the diagonal. Are those congruent? No. Is it a rectangle? No, because diagonals are not congruent. I'm not going to write that because my pen isn't working very well. I'll write it on the next slide. How about that? There you go.